In this video we're going to sketch this graph. So as always, whenever you have a rational function, you need to investigate when it will break down. Well, it will break down when the denominator equals 0. So you know it would break down when x equals 0 or when x equals positive 1. So it will break down at x equals 0 and x equals 1. Now let's investigate what happens when x is very, very large. When x is very, very large, you've got up on the numerator, you've got three blocks. When x is very, very large, let's say 1000, these two blocks are really irrelevant because 1000 cubed would be very, very big in comparison to these two, and these two blocks are really irrelevant. So when x is very, very big, you can think of this as being like x to the power of 3, because that's what's going to dominate, and in the denominator it would be this block that dominates, because this block is really irrelevant. And remember, the minus belongs to this block. So when x is very, very big, it will act like this. It will act like this. So in which case you can simplify this to being minus x. So when x is very, very big, the whole graph will act like minus x. So it will act like y equals minus x. So in your mind, draw y equals minus x, which will look something like this. But it's only valid when x is very, very big. When x is very, very big. When it's small, it's not really valid. Only when it's very, very big. So you know it will act like this. And then, hang on, we know that something fishy is going on when x equals 0. So let's investigate what happens. When x equals 0, if you put 0 into here, 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 and here, it will act like minus 2 over 0. So we have a hunch that it's going to do something like this. One shoots up, one shoots down, or it could be one shoots up like this and one shoots down. We have a hunch just by looking at this, but let's investigate more in detail. So hang on. So when x, so let's select a point just to the right of 0. So just to the right of 0, let's select a really small number, something like this. So when you put this into here and into here and into here, it's going to be approximately, well, this is going to dominate. So it's going to be approximately -2, and this thing here, when you put into here, so you have something like this, 0.004, and then take away, this thing squared will be 0.00016. So you can see that this number is bigger than this number here, and when you get a big number, take away a smaller number, collectively this thing here will be a positive number. So it's going to be a positive, very, very, very small. So you've got a negative here. Let's move this negative out here. So move it out here. So it would be this thing here, the number 2 divided by very, very small is going to be very, very big. This thing's going to be very, very big, and because you've got a negative here, it's going to be negative big. So just to the right of 0 is going to be very, very negative big. So it's going to look something like this. Use the same argument over here, and it will be very, very positive big. So you have a hunch that the graph will do something like this. You have a hunch that it would do something like this. Okay, you have a hunch that it would do something like that. But the thing is, we know that dead on, hang on, let me clean this up. But we know that dead on 1, it breaks down. We know dead on 1, it breaks down. So something's weird is happening around 1. So I don't know what's happening around 1. So let's investigate what happens when you take the limit of that whole thing. Take the limit of the whole thing as x heads towards positive 1, because we know it breaks down at 1. We just don't know what's happening around this region here. So we now need to investigate the limit of this. So far we know the graph looks like this. Very, very negative big, very, very positive big. It's going to follow y equals negative x, but it's only valid when it's big, so you ignore when it's small. So we know this so far. We now need to find the limit of this. Well, to find the limit of this, normally when we work out limits, we want to factorize it so that the numerator cancels out with the denominator. Well, the trick to finding out limits is most of the time it's going to be factorize this. Okay, so we've done limits before. One of the techniques we would use is to factorize this. So let's try and factorize this. So factorizing it sets the numerator to 0, and then let's try and factorize it. So to factorize it, have a quick glance at this thing. You see, just by glancing, I know that 1 cubed plus 1 take away 2, it will be 0. So I know that 1 will make the whole thing 0. So I know one factor will be x. Because this is going to be positive 1, I know this is going to be one factor. And I'm expecting you to be able to factorize this. So, hang on. So, x minus 1 will be one factor. Because I'm trying to factorize this thing, this is going to be to the power 3. There is no x squared. That's why you've got a 0 here. And there's 1x here. And negative 2 here. So what I'm trying to do here is to rewrite this thing as equal to x minus 1, because I know this is a factor, and it would be something of this form. Okay, this is what I'm trying to figure out. So to do this, what's this thing divided by this thing? Well, the way we would do it is, I'm thinking of something to give me x to the power of 3. Well, and again, I'm expecting you to know how to do this. This is going to be x squared. So now x squared times this, it would be x to the power of 3. X squared times this would be negative x squared. So now, hang on, and remember, I'm expecting you to be able to do this. So this thing take away this thing would be 0. This thing take away negative x squared would be positive x squared. And I'm just going to carry this thing down, plus x minus 2. So now I'm trying to figure out this times this to give me x squared. Well, this is going to be x. So this times this will be x squared. This times this will be minus x. So now I would get this thing take away this thing. So this take away this would be 0. This take away this will be, sorry, this take away negative x. So that would be x minus x squared. So that would be 2x. And then I'm going to carry the minus 2 down. So now I need something. I need to create this. Well, I'm going to need a 2 here, because this times this will give me 2x. This times this will give me minus 2x. So now this would be 0 minus 0. So this is what I'm trying to figure out here. So wait there. Going back to here. So I know this is one factor, and then this thing here, what we've just figured out, x squared plus x plus 2, x squared plus x plus 2, x squared plus x plus 2. So I've just factorized it. This thing, you can factorize it as this. So now we can rewrite this thing here as one factor, and then times this thing here. And then notice that this is very similar to this, but it's I need a negative x up here, and then this is negative 1 and this is positive 1. So what I'm going to do is I'm going to factor out the negative 1. So I'm going to imagine this block as being negative 1 times this thing here. So now these two blocks are exactly the same. They will cancel each other out, giving you this. So now when you put 1 into here, you're not dividing by 0. The denominator is 1, which is legitimate. And when you put this thing into here, the limit is actually negative 4. So what that means is, as x tends to 1, so as the graph is moving towards 1, you will have a limit of negative 4. So so it's heading towards negative 4. Dead on 1 it breaks down, so you have to have a loose circle here. Now, so we have a hunch that the graph will look something like this. If you want to know the turning points here and down here, then you have to differentiate it. But roughly, it will give you a graph looking like this. So if you plot it into Desmos, it will give you this graph. And notice that dead on 1, it breaks down. That's why you've got a circle here. And then as you take the limits, as x heads towards 1, you can see that it's heading towards negative 4 right here. And that it is following y equals negative x. And you know that one's going to shoot down and one's going to shoot up. So your graph will look like this. Okay.